Hey everybody, this is the second part video for my grade 12 essential math students, second part of lesson 4 about calculating whether or not a bank will get you a mortgage and what kind of mortgage a person would qualify for. And in the first two examples that we did in the last video, we started with a home that somebody wanted to purchase, and we used the GDSR formula to determine whether or not they'd be approved. And most of the questions in assignment 4 for the homework work that way, but a couple times they ask you the question backwards. Instead of, here's the price, can I afford it? It asks the question backwards in terms of, all right, here's the situation for this couple or this person trying to buy a house. How much house can they afford? So if they're asking it backwards, there's two ways you can do it. One is to do this fairly lengthy but not really very complicated thing called an affordability chart. So example 3 would be somebody at a bank would have this chart and they'd fill it in based on the particulars of the person, the client that they're working with situation. So a person decided to buy a house worth $85,000. Can they afford it? In other words, what we're going to do is we're going to find out if the biggest possible house price that they can afford is enough for them to buy an $85,000 house. So I'm going to work through this kind of form and see if the number at the bottom is as big as $85,000. So let's start with how much do they bring in every month? What is their gross monthly household income? So let's read the whole question. A person decided to buy a house worth $85,000. The down payment will be $6,000. The monthly property taxes are $120. The heating costs are $110. Calculate the maximum affordable price, the monthly mortgage payment, and the gross debt service ratio if the bank will finance the house at 7.5% for 25 years. Okay, so their gross monthly income is $2,500, so that's going to go right here, $2,500. Now, it tells me what to do in these charts. Multiply this by the gross debt service ratio, and remember you can't really multiply by a percent, so you have to change that to 0.32 times the 2,500, and there we go. So that's an $800. So that basically represents the largest mortgage payment they can make before expenses. But of course we have to worry about expenses. So their monthly property taxes are $120. Their monthly heating costs are $110. This is only if they're buying a condominium, because if you buy a condominium, you have to usually pay condo fees, or they're sometimes called strata fees, which is the fees that you pay towards your condominium's building owner to do things like the maintenance on your condominium. Like when you own a condominium, you're not usually responsible for maintenance on your home and stuff. We're going to talk more about that in later chapters, but basically in this problem it doesn't say we have one, so we'll just leave it blank. So take the 800 and minus, it even says subtract those two numbers. So I can do this in my head. 800 minus 100 is 700, minus 20 is 680, then minus another 100 and minus another 10 is $570. So that actually now is the most affordable monthly mortgage payment they can make. So that's actually one of the things they wanted, the monthly mortgage payment. So it calculate the maximum affordable price, which is going to be at the bottom, but we've already found the most affordable mortgage payment they can make is $570 a month. Okay, so we're going to divide an interest factor from a table. Now, I haven't shown you this table yet. It's again at the back of your booklet. In fact, I think it might even be the last page where all the tables and charts are. And notice there's another blank one of these forms if you want to use it to do another question later. And you just look up, it was a 7.5% mortgage for 25 years. I think all of these are based on 25 years, so you only have one chart to look up. And 7.5% has a interest rate factor of 0.00732. So make sure you copy that number properly. Don't forget the extra zero there, 0.00732. And it says to divide this number by that interest factor. So I'm going to do that. So I'm going to take $570 and divide by, let's see, I'll do it over here so you can see better, 0.00732. and that gives me an affordable mortgage of $77,868, and then watch out, this is money, so round it to the nearest cent, and 85 cents. Now, they do have a down payment, right? They have a down payment of $6,000, so put $6,000 here, and this actually answers the question, what's the biggest mortgage they could get? This answers the question, what's their biggest down payment they can, biggest monthly payment they can afford. And now add this and this together. So just add 6,000 to this. And there you go. That is the absolute highest price that they can afford to pay for a house. So that'd be $83,868.85. And so in this case, they are looking to try to buy a house worth $85,000, so they're just short. Therefore, no, they will need to find a less expensive house. Okay. So that's how you use the affordability chart. That's not the only way to do one of these questions. Another way to do it is to stick with the formulas we already know, but work them backwards by using variables. In other words, yep, it's algebra. So if you don't like using algebra, if you're one of those people who say, the reason I didn't take applied or pre-cal is because I hate algebra and I'm not good at it, well, these charts always work. Just print yourself off another blank one of these charts or copy it into your notebook and follow the steps and you'll get the right answer. But for those of you who don't mind doing a little bit of algebra, and I think some of you have already tried, I think it's question number 4 in assignment 4. Some of you have already gotten it using this method. Congratulations on the people who figured it out for themselves. But basically I'm going to do a similar question the same way, but I'm going to use the algebra method instead of this chart. So Gregory has $12,500 saved up for a down payment. He earns about $2,800 each month using a bank rate of 7% and estimating the monthly property taxes to be $180 and the monthly heating cost to be $125. Determine the maximum amount of mortgage he'd be given. Somebody asked me the other day, like, what about, it said utilities in the formula. Heating isn't the only utility. What about your phone? What about your internet? What about all that? Keep in mind, in a real life situation, you'd have to have more than just this as your utility. They're simplifying it while we learn how the formulas work. I mean, let's face it, these prices are not all that realistic in the modern house market anyway. Nobody's buying houses for $83,000, at least not in major cities anyway. So keep in mind that this is kind of simplified. So if you were wondering, hey, what about other utilities? Don't worry about that so much. So the formula is, remember how the formula works? The formula is, if I could just go back to the GDSR, is the monthly mortgage payment plus the utilities payment plus the property taxes, all divided by the gross monthly income times 100. And we actually know that you will not get approved unless this number is less than or equal to 32. So if I'm looking for the maximum amount they can afford, I guess I want to go right up to that limit of 32%. So here's what I know. I know this number is in the first part of this lesson, we were calculating this number and then comparing it to 32. Well, I know that this is the number I want here, and I actually know all but one of these numbers. I don't know the monthly mortgage payment. Let's call that X, which is what you do in math when you're solving for an unknown number. The utility payments is 125, right? That's the heating cost. The property taxes is 180. And the gross monthly income is $2,800 a month. And so I am going to just do algebra. Okay, I'm going to do one thing first. I'm going to actually simplify this a bit. I'm going to change this to X plus, and then 125 plus 180. If I add those two things together, that's going to be, what is that, 305? All over 2,800 times 100 equals 32%. Okay, now the basics of algebra. How do you get this X isolated? Well, think of X as being a number that, if you follow BEDMAS, is being added to this, then divided by that, then being multiplied by that. You have to undo those three steps. and you have to undo them in the opposite order. Right? The last thing I did was times it by 100. So the first thing I'm going to do is undo timesing by 100. What's the opposite of timesing by 100? And you'd be right if you said, well, you divide by 100. So to both sides of this equation, divide by 100. On this side, it cancels the 100. And on that side, it turns 32% into 0.32. Now, how do I undo dividing by 280? What's the opposite of that? Timesing by 280. So if I times both sides by 280, it cancels on that side, leaving me this. And I can't do this in my head. 0.32 times 280 is 8. Is that 89.6? Yeah, 89.6. And then, let's see. Oh, wait a minute. This should be 100. I was just going to say that's awfully low. So 896. And then minus 305 from both sides, because that's the opposite of adding it. And I just realized I had the wrong number, so that's not going to work. Let me just punch it again. 0.32 times 2800 equals, and then minus 305. There we go. Now we're on track. So there it is. $591 is his absolute maximum mortgage payment. So that's the amount of mortgage payment he can make each month. What's the maximum amount of mortgage he'd be given? Well, go back to the formula from lesson 1, right, where we did monthly mortgage payment. So mortgage payment, it was equal to the amount of the mortgage. Oh, thank you, Norton, for taking care of stuff. The amount of the mortgage divided by 1,000 times my table number. Remember that? Now, I actually kind of already know the table number. It doesn't tell me that it's a 25-year mortgage, but look, it says that I want the maximum amount of mortgage he'd be given. It should make sense to you that if he's going for the maximum amount of mortgage he could get, so to buy the most house that he can, he's going to just automatically ask for the biggest term, the biggest amortization term possible, right? If you wanted to pay a mortgage in less years, it's going to cost you more each month, and it's going to be more towards interest. So you're better off with, you can buy more house with a longer mortgage. So I'm just going to assume that it's the 25 years, and I'm going to go back to this table here and find a table value for 25 years at 7%. So 25 years, 7%. Oh, look at that, it's 7. That's a nice coincidence. So the table number is 7. I'll put the 0.00 even though I don't need them. I don't know the mortgage amount. That's what I'm looking for. And I know that the monthly payment is $591. I calculated that here. And I know I'm dividing by 1,000. And once again, it's algebra. How do I get x by itself when x is being divided by this number, then times by that number? Undo those two steps. Take 591 and divide by 7, because that's the opposite of times. And then it was being divided by 1,000, so times by 1,000 is the opposite. And there we have it. That's the biggest possible mortgage that this person could get at a 25-year mortgage. And just for fun, if you wanted to figure out, well, what if he wanted a 20-year mortgage? Could he actually buy more house? Well, no, because think about it. That would mean I would be 1 over on this chart here, and instead of the 7, it'd be 7.7, which would mean this number would be 7.7, and then I'd be dividing 591 by a bigger number, which would make it smaller. So I'd end up smaller than that. So that's why I knew to get a maximum for him, I have to go to 25 years. That's why the question didn't have to say it. I just knew that that's what it would be. Somebody did ask me the question, can't you get a longer mortgage than 25 years? My parents have one, and actually, yeah, nowadays they do actually in some banks and financial institutions offer 30-year mortgages. But once again, to keep problems simpler and to not have to print new ones of these, we're going to just assume 25 is the biggest you can get for all our problems. So now, if you were stuck, oh, speaking of stuck, my cam's frozen, there we go. If you were stuck on a couple of the questions in the assignment 4, if you were already well into assignment 4, you can try them now. I think number 4 is this way. You can try it either using this method or the algebra method, and you should be just fine trying to get through them. I'll be live streaming later if you have any other questions. Thanks for watching, everybody, and that's it for lesson 4.